Show all the steps in how you'll carry out the following synthesis. So this is another synthesis kind of a problem. Syntheses are usually a little bit more challenging because you have to put two or three things together, two or three reagents together. You want to make sure that they're all in the right order also, okay, when you do this. So let's see, here we are starting with an alkane and we are going to an alkyl halide, okay? So this kind of a reaction is, of course, a substitution. Okay, on the other hand, you can look at it differently because you know that if you're trying to do substitution, is not going to work because hydrogen is a terrible leaving group. Okay, so this substitution is not going to work. Okay, so change of thinking now. All right, so if you can't do elimination on this one, then what? Okay, can you do on the, excuse me, when you can't do substitution on this one, then what can you do? So the other strategy would be to add something on here on the alkane, have it leave, and then add the bromine according to what you want. Okay, and so you can drive the reaction yourself. And this is really, one of the best aspects about chemistry is that you can create your own thing, provided you know the proper reagents, okay, in there. So let's go ahead and get started with this. Again, with alkanes, you really cannot do a whole lot because alkanes are very boring. The only thing they do is burn in oxygen. And the second thing they do is react with bromine or chlorine if you do a free radical reaction on it. Now remember, bromine will always go to the carbon that is the most stable carbocation, in this case carbon radical. Okay, so this is the only location where you can actually have bromine. All right, there is no other location you will go for, so this is going to be the major product. Okay, so now what we need to do is we need to do elimination here. When we do the elimination here, looking at the location of our bromine in the final product, we need to make sure that our alkene actually formed between these two carbons, because that is how we are going to go ahead and add the bromine, okay, on there. So how do we get this specific alkene? Now this kind of an alkene is what we call Zaitse's product, okay, because this is an internal alkene. So this is the Zaitse's kind of alkene or Zaitse's product. So to form Zaitse's product, okay, you can have an E1 elimination, and also because remember this is a tertiary halide, so which means that the conditions are perfect. Okay, so in this case you can also do solvolysis if you wanted to, or you could just go ahead and use a nice small base. Okay, so here is the hydrogen, and you can use hydroxide, okay, and just go ahead and add heat on there, because heat will tell you that you are trying to do elimination rather than substitution, okay, on there. So you can use that. Can you use t-butoxide? I would suggest not for this elimination, because the hydrogen here is not that easily accessible. So t-butoxide is really good if you want to make a Hofmann alkene, okay, not for Zaitse's alkene. All right, so in these cases you need to use a small strong base along with heat. Okay, that should give you a nice Zaitse's product. The last step that we had is we need to add bromine on here. Okay, so how do we do that? So we've learned the reactions of alkenes, okay, where if you have an alkene like this and you add HBr to this, this is going to be a Markovnikov's addition. Markovnikov addition means hydrogen goes to the carbon with more hydrogen. Okay, so here you're looking at the number of hydrogens you have, and this is the carbon with the more hydrogen. So if this is the carbon with the more hydrogen, you want bromine there, you don't want hydrogen there, which means that whatever you want here has to be anti-Markovnikov. So these are things to keep in mind as you're doing a synthesis, which means you still need the bromine, you just need the conditions to be different. If you were to use just HBr, then you will get the Markovnikov product. But if you use HBr along with light, then you get anti-Markovnikov, okay? And this was actually in the free radicals chapter that we did. So that's the one thing about the synthesis at the end of the semester, is that you have to start putting everything together, from substitution, elimination, free radicals, alkene reactions, everything together. Okay, so again, this is just a 3-step process. It's not very long. So you do the free radical substitution first, then you do the elimination, and then the anti-Markovnikov addition, okay, to get the final product.